Hey guys, what's up? We're going to look at nuclear radiation. But before we begin that, let's look at a fundamental law of the universe. And it's a law to do with the fact that the universe goes from an unstable state to a stable state. And understanding this principle will help us understand the idea behind nuclear radiation. So if you consider a ball on top of a hill, like we can see here, this ball on top of the hill has got lots of gravitational potential energy, and it doesn't really like having this extra energy there. It would rather roll down the hill and become stable. As it does this, the GPE gets converted into kinetic energy, and eventually that kinetic energy will be dissipated as thermal energy to the surroundings. And the ball has become more stable. It's in a much more stable configuration now. And it's also got less energy than what it began with. If you look at a bomb, and this bomb is going to blow up, it's got loads of chemical energy stored in it. And it wants to explode. As soon as there's enough activation energy to start the chemical reaction, it will explode and it will become more stable. The thermal energy will be dissipated once more. And if you think just about something simple as a cup of tea. So here I've got a cup of tea and it's really hot. All that thermal energy is stored within that cup of tea. That's an unstable configuration. And just like everything else in the universe, it wants to become stable. It wants to become cold. By doing this, it gives off thermal energy to the surroundings. And the spreading out, the dissipation of this energy to the surroundings makes the universe more stable. This applies to everything. Everything naturally left to itself will go from unstable to stable. So let's have a look at nuclei now. So nuclei, as you should know, are the central part of atoms. And scientists once upon a time believed the fact that nuclei would be stable if the number of protons was exactly equal to the number of neutrons. So this dotted line here, the black line, is this line that they thought would be the line of stability. But when you actually plot a graph of the number of protons versus the number of neutrons for the stable nuclei, you get this green line. And we call this line the line of nuclear stability. So those are actually the stable nuclei. And as you can see, there's actually, as you get to heavier and heavier nuclei, the ones up here, for example, there's actually a greater number of neutrons than there are protons. The reason for that is that protons are positive and they repel each other. So you need more neutrons in there to glue the nucleus together through what's known as the strong nuclear force. So this green line of stability doesn't follow this 1-to-1 ratio of protons to neutrons. There are other nuclei though. The green ones are the stable ones. The ones that lie on that green line are stable. But you've got all these other ones which I've drawn as little dots. These represent different isotopes of different elements. The ones in red at the very top of the graph, so up here, we've got a section where I've coloured lots of these nuclei in red. These are ones that are unstable. And the way that they become stable to get onto the green line is that they do alpha decay. And we'll talk about that later, and we'll look at alpha decay in another video. The ones here above the green line, these decay by what's known as beta minus decay. And that enables them to become stable. So they do this randomly and spontaneously. By decaying through alpha or beta decay, as we've seen with these two, they get themselves onto this green line, this line of nuclear stability. The yellow ones with light nuclei at the bottom, they decay via what's known as neutron decay. This has only just been added to the GCSE course, so you do need to know about that. The ones here in orange, which are below the green line, we actually don't need to know about for GCSE, but it's called beta plus decay. But if you study A-level physics, you'll learn more about that. So we'll just ignore beta plus decay. The important thing to remember here is that there is a line of nuclear stability, and all of the nuclei eventually want to get onto this line. And the way they do that is through either alpha, beta minus, or neutron decay. There is another process called gamma decay, but we can't represent it on this graph here. So we've said that everything in the universe wants to go from unstable to stable. It's a fundamental law of the universe. So here I've got an unstable nucleus. Obviously, nuclei don't have faces, but I'm just trying to represent that it's unhappy. It's got too much energy and it wants to somehow lose it. It wants to become this nice, stable, calm nucleus. And the way that it does that is through radioactive decay. So radioactive decay is simply the process by which an unstable nucleus becomes a stable nucleus. And there's 4 different ways which you must know for your exams about how they do that. One way is that they can simply get rid of what's known as an alpha particle. So this is alpha decay. And an alpha particle is a helium nucleus. It's made of 2 protons and 2 neutrons. And when this unstable nucleus kicks off this helium nucleus, this alpha particle, it loses energy through the form of kinetic energy, and it loses mass energy also. The second way is what we've seen, beta minus decay. And this is where the nucleus actually emits a fast moving electron. This is a little bit more complex because nuclei don't have electrons. Electrons are found in the shells normally of atoms. But something happens in the nucleus, which we'll look at in another video, which causes the emission of an electron, which reduces the energy of the nucleus, enabling it to become stable. The third way is that the unstable nucleus can emit an electromagnetic wave. And this electromagnetic wave is very high energy, and we call it gamma decay, because it's a very high frequency, very high energy, and very small wavelength electromagnetic wave, and it's simply a way of the nucleus getting rid of excess energy. The fourth one, which I said is new to GCSE, is neutron decay. And this generally only happens with very light nuclei that have got simply too many neutrons, and they can afford to get rid of it to get onto that green line of stability. So, if we just summarize that, nuclear radiation is radiation emitted from unstable nuclei, enabling them to become stable. And there's 4 ways: alpha radiation, beta radiation, gamma radiation, and neutron radiation. In another video, we're going to look at each of the properties of each of these different types of radiation, because you do need to understand them in a lot of detail. So to summarize everything, the universe goes from unstable to stable. And where every single nucleus wants to be is on this line of nuclear stability. The way they do that is through emitting nuclear radiation. If they are not on that line, if they're below it or above that green line, they want to get onto that green line, they want to become stable. So they emit nuclear radiation, which is radiation emitted from unstable nuclei. And the 4 types are alpha, beta, gamma, and neutron decay. And that enables these unstable nuclei to become stable. That's it. Thanks for listening. See you all soon.